There are over 360 million acres of land in Alaska. In the organized boroughs, property tax assessment boards are hiking valuations by more than 7% a year. If you build a traditional cabin on a concrete foundation, the local tax assessor shows up, appraises your hard work. Every year, the bill gets larger, and there is nothing you can do about it, because the moment you poured that foundation, you converted your shelter into real estate, and real estate in an organized borough is taxable by definition under Alaska state law. A growing number of working-class Alaskans have done the math on that arrangement and decided it does not work for them. They have found something else. A structure that is fully weatherproof, engineered for extreme cold, capable of surviving an Alaskan winter at -40, and completely outside the legal definition of taxable real property. They build them on wheels. This video documents exactly how it is done, the legal classification that makes it work, the structural engineering behind why a steel arch on a flatbed trailer outperforms a wood frame cabin in conditions that destroy conventional construction, the thermal strategy that makes a metal building on a trailer survivable when the temperature drops to ranges that kill exposed pipes in under an hour, and the parts that most videos on this subject leave out entirely, including the real startup costs, the zoning realities, and the maintenance demands that nobody talks about until the second winter. This is not a legal recommendation. Alaska statutes vary by borough, classifications shift, and anyone making decisions about property, taxation, or land use should verify the current rules with a licensed attorney familiar with Alaska municipal law. What follows is reported for documentary purposes, to explain a phenomenon that is growing quietly across the state among people who have decided that the standard path, the mortgage, the foundation, the escalating tax bill, is a worse deal than the one they can build themselves. Under Alaska state law, property taxation is triggered by a specific legal condition. The tax applies to land and to permanent structures that are affixed to real property. That word, affixed, is doing the entire legal job. A building that is bolted to a concrete foundation, connected to municipal utilities through permanent underground lines, and recorded with the borough assessor as an improvement to a parcel of land is real property. It is taxable. The assessment goes up when the market goes up, when comparable sales in the area go up, and when the borough needs more revenue and adjusts its mill rate accordingly. The owner has no exit. The structure is legally part of the land, and the land is inside the borough, and the borough taxes everything inside it that qualifies as real property. A structure built directly onto a heavy-duty flatbed or gooseneck trailer does not meet that definition. It has no foundation. It is not affixed to any parcel. It can be connected to a truck and moved within hours. Under the classifications used by many Alaska jurisdictions, that structure is personal property, the same legal category as a vehicle, a boat, or a piece of equipment. Personal property in Alaska is either taxed at a much lower rate than real property, taxed only in specific organized boroughs that have adopted personal property tax ordinances, or not taxed at all. The distinction matters most in the unorganized borough, which covers roughly half the land area of the entire state. The unorganized borough has no borough government and levies no property tax of any kind. Approximately 84% of Alaska's total land area sits outside the boundaries of any organized borough. A mobile structure parked on land inside the unorganized borough or on state land under a valid permit or on private rural land in an area with no organized taxing authority generates zero property tax liability by default. The mobility factor adds a second layer of protection that permanent structures cannot provide. Organized borough boundaries are not static. As Alaska's population shifts and as borough governments pursue incorporation or annexation, the taxable boundary lines move. A homeowner with foundation inside an expanding borough boundary has no legal recourse. The expansion happens, the assessor arrives, and the tax bill starts. A homeowner with a trailer-mounted structure has a different option. They pull the jacks, hook up the truck, and relocate outside a new boundary. The structure moves with them. The tax exposure disappears. This is not a theoretical scenario. Several Alaska borough expansions over the past 2 decades have converted previously untaxed rural parcels into taxable real property overnight. The people who build on foundations absorbed the new tax burden. The people who built on trailers moved. The legal classification is the reason this strategy exists. The engineering is the reason it actually works in Alaska specifically, because building on a trailer frame in sub-zero conditions introduces a set of structural and thermal problems that eliminate most conventional construction approaches before they start. The fundamental problem with any trailer-mounted structure is that the trailer frame flexes. Gravel roads in rural Alaska are not paved, are not graded regularly, and in breakup season become a series of frost heaves, soft shoulders, and unpredictable surface failures. A structure that gets towed down those roads has to absorb that movement without cracking, splitting, or losing structural integrity at its joints. Traditional wood frame construction fails this test. Dimensional lumber joints are designed for static loads, not for the dynamic flex and twist that happen when a trailer crosses an uneven surface at highway speed. The joints crack, the sheathing separates, the drywall, if there is any, splits along every seam within the first 2 or 3 transport cycles. Steel Quonset arch construction solves the flex problem through its geometry. The corrugated steel arch panels that form the walls and roof of a Quonset hut are not a frame covered by a skin. They are a monocoque structure, meaning the skin itself is the structural element. The arch shape distributes load continuously along the curve rather than concentrating stress at discrete joints. When the trailer flexes on an uneven road, the arch panels flex with it and return to their original geometry without permanent deformation. There are no interior load-bearing walls to crack. There are no ridge beams to fail. The arch is the entire structure, and the arch is designed by geometry to absorb and redistribute force rather than resist it rigidly. The snow load performance of the arch shape is the second engineering reason this approach dominates in Alaska specifically. Flat roofs and conventionally pitched roofs accumulate snow. In south-central and interior Alaska, a single winter storm can deposit enough snow to add several thousand pounds of dead load to a roof structure. Flat roofs fail under that load. Conventionally pitched roofs hold snow at the angle points and along the ridge. The curved Quonset arch sheds snow continuously. As the snow accumulates, its own weight causes it to slide down the curve and off the sides of the ground. The roof never accumulates a significant static load. This is not an incidental benefit. It is a reason Quonset arch structures have been used in Arctic and subarctic military and industrial applications since the 1940s. The geometry does the work that structural engineers would otherwise have to solve with heavier, more expensive framing. The trailer weight distribution problem is solved by the Quonset arch's low mass relative to its enclosed volume. A steel arch kit for a 10-foot by 24-foot structure weighs significantly less than the equivalent volume in wood framing, sheathing, roofing material, and interior finish. The lower total weight means the trailer axles carry less dead load, leaving more of the legal gross vehicle weight rating available for insulation, heating equipment, stored supplies, and personal property inside the structure. A dual-axle heavy-duty trailer rated for 14,000 pounds of payload can support a fully insulated and equipped Quonset structure and still remain within legal road weight limits for transport on Alaska state highways. The steel arch kits themselves are available from several manufacturers who ship to Alaska, with base kit prices for a 10 by 24 footprint running between $3,000 and $5,000 depending on gauge, panel profile, and included hardware. That is the cost of the steel only, before insulation, before the trailer, before the heating system. The total budget question gets addressed directly in the final section of this video, because it is the part that almost nobody covers honestly. The thermal problem specific to trailer-mounted construction in Alaska is not the same as a thermal problem in a ground contact building. In a conventional cabin, the ground itself acts as a thermal buffer. Even in interior Alaska, the ground temperature a few feet below the frost line holds at a relatively stable temperature year-round, and that stability prevents the worst of the cold from entering through the floor. A trailer has no ground contact. The floor is suspended above grade, and cold air moves freely underneath it. At -40, the air under the trailer floor is the same temperature as the outside air, and it is moving. Wind chill on the underside of the trailer floor in an Alaskan interior winter accelerates heat loss through the floor by a margin that eliminates any conventional insulation strategy that does not account for it specifically. The thermal strategy that experienced builders use in Alaska has 3 distinct layers, and all 3 are required. Leaving out any one of them produces a structure that is uncomfortable at -10 and dangerous at -30. The first layer is the thermal break at the trailer bed. Steel conducts cold with almost no resistance. If the insulation system begins at the interior wall surface without addressing the steel ribs of the trailer frame and the steel arch panels directly, those metal elements act as thermal bridges, conducting outside cold directly into the living space and producing condensation on every cold surface they contact. Condensation inside an insulated wall cavity is how rot and mold begin, and in a steel structure, it is also how rust begins from the inside out, which is a structural failure mode, not just an aesthetic one. The correct sequence is rigid board insulation laid directly on the trailer bed before the subfloor is built, a wooden subfloor frame constructed on top of the rigid board to create a thermal break between the steel trailer frame and the living space floor, and closed cell spray foam applied to the interior surface of the steel arch panels before any interior finish goes up. Closed cell foam adheres directly to the steel, seals every gap and penetration, and provides an R value of approximately 6 to 7 per inch. At 3 inches of thickness on the arch interior, this produces an insulated envelope capable of maintaining a meaningful temperature differential between inside and outside, even at the extremes of interior Alaska winter. The second layer is a heat source, and the selection of that heat source matters more in a trailer-mounted structure than in a conventional cabin, because the interior volume is small and the insulated envelope, while effective, is not perfect. The most reliable primary heat source in documented Alaska trailer builds is a small high-efficiency wood stove or diesel parking heater. A wood stove in a 10 by 24 footprint with 3 inches of closed cell foam on the walls, and ceiling will bring the interior from ambient outdoor temperature to 70 degrees Fahrenheit in under 20 minutes using a small quantity of dry split hardwood. The thermal mass of the steel walls and the concrete board or tile typically used as floor finish in front of the stove absorbs and slowly re-radiates that heat for hours after the fire dies down. Diesel parking heaters, the same category of unit used in long-haul trucking, are a cleaner secondary or backup option. They run on the same diesel fuel that powers the truck used to tow the structure, require no chimney penetration larger than a small exhaust pipe, and can be thermostatically controlled to maintain a set interior temperature without a tension. The fuel consumption that sustains cold weather operation runs approximately 0.1 to 0.2 liters per hour at low settings, which means a 20-liter fuel to provide several days of continuous low-level heat. Both sources together, the wood stove is primary and the diesel heater is backup, give the occupant redundancy in a context where losing heat at -40 is not an inconvenience. It is an emergency. The third layer is off-grid utility management. A trailer-mounted structure in rural Alaska is not connected to grid. Power comes from a 12-volt lithium iron phosphate battery bank charged by a solar array, a generator, or both. A properly sized Leaf PO4 system for a single-occupant structure running LED lighting, a diesel parking heater's control electronics, phone and device charging, and a small water pump requires approximately 200 amp-hours of usable battery capacity. A 200-watt solar array in south-central Alaska provides meaningful charging from March through October. For the winter months, a small gasoline or propane generator provides supplemental charging. Water is stored in 5-gallon jerrycans kept inside the heated living space. This is not optional in Alaska. Water stored in an unheated exterior compartment freezes solid at -10 and does not thaw until spring. Keeping water inside the thermal envelope means it remains liquid as long as the heating system is functioning. Gray water from cooking and washing drains through a simple slope pipe to a collection container or a gravel dry well, depending on the land use situation and local regulations. Now, the reality check, which is the section that most videos on this subject leave out entirely, because it requires saying numbers out loud that do not fit the thumbnail. A heavy-duty dual-axle trailer capable of supporting a Quonset structure and meeting Alaska road weight requirements costs between $4,000 and $8,000 for a used unit in serviceable condition. A new trailer of the same specification runs $10,000 to $14,000. The steel arch kit for a 10 by 24 footprint runs $3,000 to $5,000. Closed cell spray foam applied professionally to the interior arch surface of a structure that size costs $1,500 to $2,500. Rigid board insulation for the trailer bed and subfloor framing adds another $400 to $700. A quality wood stove with chimney hardware runs $600 to $1,200. A diesel parking heater with installation hardware runs $300 to $600. A 200 amp hour Leaf AP04 battery bank with a basic solar charge controller and a 200-watt panel runs $800 to $1,400. The honest total for a complete, functional, winter-ready mobile Quonset structure built in Alaska in 2026 is between $11,000 and $22,000, depending on whether components are sourced new or used, and whether the builder does the labor personally or hires it out. That is not pocket change. The video description that implies this is an accessible project for someone starting with minimal resources is doing those people a disservice. What it is a fraction of what a conventional cabin costs. A site-built wood frame cabin in Alaska, including materials, foundation, septic system, and well, runs $150,000 to $300,000 before the first property tax bill arrives. The mobile Quonset structure, at its most expensive honest bill cost, is roughly 1/10 of that. And the property tax bill never arrives, because the structure never becomes real property. The zoning reality is the second thing that most videos on this subject misrepresent. The personal property classification eliminates real estate property taxes. It does not eliminate every other legal consideration. A municipality or borough with active code enforcement can classify a permanently occupied trailer structure as an illegal camping violation, a zoning violation, or a nuisance, regardless of its property tax classification. The strategy of building on wheels works cleanly in the unorganized borough, on rural private land in areas without active zoning enforcement, and on land where the owner has verified the local rules and confirmed that no ordinance prohibits it. It does not work on a residential lot inside Anchorage, Fairbanks, or Juneau city limits without triggering enforcement action. The practical land strategy that experienced builders use is to identify unzoned state or borough land available for long-term use permits, to use rural family parcels that have been in agricultural or homestead use, or to purchase raw land in remote areas where the purchase price is low precisely because there is no infrastructure and no organized municipal services. The same conditions that make rural Alaska land cheap, its distance from services and its absence from organized borough jurisdiction, are the conditions that make the mobile Quonset strategy viable. Trailer axle maintenance is a third reality that gets omitted. A structure that never moves is still a trailer. The axles, bearings, brakes, and coupler hardware require inspection and service on a regular schedule regardless of how often the trailer actually gets towed. Bearings that sit loaded and stationary in Alaska winter conditions develop flat spots and corrosion that can cause catastrophic failure on the first tow after a long stationary period. Brake components on electric over-hydraulic systems require annual inspection. Tires develop sidewall cracking from UV exposure and ozone degradation even without road wear. A trailer that has not been maintained is not a mobile structure in any meaningful sense. It is a permanent structure with wheels that do not work. Maintaining the mobility, which is the entire legal and practical basis of the strategy, requires treating the trailer as a vehicle and servicing it accordingly. The risk and reward calculation for someone seriously considering this approach is straightforward once the real numbers are on the table. A conventional path in Alaska, mortgage on a site-built home with a foundation, runs $1,500 to $2,500 a month for principal, interest, and property taxes on a modest structure for 30 years in an environment where assessed values are rising and tax rates are not declining. The mobile Quonset path runs $11,000 to $22,000 up front, with no mortgage, no property tax, and monthly costs limited to fuel, maintenance, and whatever land use fee or permit applies to the specific location. The total 10-year cost of the conventional path at the low end exceeds $180,000. The total 10-year cost of the mobile Quonset path, including the full startup costs and generous ongoing expenses, is under $40,000 in almost every scenario. The people building these structures are not doing it because it is romantic. They are doing it because the math is not close. The system is designed around the assumption that you will take the mortgage, build on the foundation, and pay the tax bill every year for the rest of your life. The assumption is not unreasonable. Most people do exactly that. But the Alaskans building steel arches on flatbed trailers have looked at the same numbers and reached a different conclusion. They are not avoiding responsibility. They are not breaking any law that applies to their situation. They are using the legal classification system exactly as it is written, building structures that the law defines as personal property, in locations where that classification means a tax collector has no claim on them, and doing it with engineering that is genuinely suited to the environment they live in. The steel arch has been doing this work in the Arctic since before most of the people watching this video were born. The flatbed trailer has been legal personal property under Alaska statute for the entire history of the state. The combination of the two, in the context of organized borough tax expansion and rising mortgage costs, is not a new idea. It is an old idea that the current economics of Alaska housing have made newly rational. If you found this useful, subscribe. We document the engineering, the legal structure, and the real costs of off-grid construction in Alaska. No thumbnails that lie about the budget. No scripts that skip the maintenance chapter. Just the math, the materials, and the method that people are actually using to build shelter in one of the most demanding environments on Earth. Outside the system that keeps telling them the only option is a 30-year mortgage and a tax bill that grows every year until they die. The land is there. The steel is available. The legal classification is written into Alaska statute. The people building these structures figured it out without a government program, without a subsidy, and without anybody making it easy for them. They just needed somebody to explain how, and to be honest about the costs, the zoning, the maintenance, and the math.